Vacuum Adsorption Transfer System Model Selection Software. Welcome to this module on Vacuum Adsorption Transfer System Model Selection Software. At the end of this module, you will be able to access the Vacuum Adsorption Transfer System Model Selection Software, select vacuum equipment based on the specifications of an application, calculate the specifications of vacuum equipment in an application, and improve an existing vacuum circuit. You can find the latest version of the Vacuum Adsorption Transfer System Model Selection Software on the SMC website at www.smcworld.com/select/EN, or just click on this link. We are now on the Model Selection Software page. Scroll down to find Vacuum Adsorption Transfer System. Click on it to go to the Vacuum Adsorption Transfer System page. You can set your geographic area, country, and language details from the drop-down list at the top of the page. You will also see the SMC products that can be used with this software under Target Selection Series. Precautions on the use of this software and the minimum web browser requirements are also shown here. Please make sure that you read and understand these points before moving on to the next stage. Click on Next. This software has two functions: model selection and characteristics calculation. The model selection function helps the user select optimally sized components, which satisfy a set of specifications based on the user's application. Characteristics calculation, on the other hand, is used for calculating vacuum specifications based on the user's application or input condition. Both functions follow the same selection process, the only difference being in the input data and selection results section of the software. We will begin by selecting Model Selection from the options available. Once the Model Selection part of the module has been completed, the differences between the input data and the selection results will be explained. For the purposes of this example, we will assume the following user specifications in order to select the correct components for the application. The workpiece will be a rough piece of wood of 1 kilogram mass, with a width of 100 mm and length of 200 mm. System operating pressure 0.5 megapascals. Adsorption time should be less than 0.5 seconds. Vacuum pressure -60 kilopascals, and our circuit will have a separate supply and release valve. Now let's look at the model selection system construction. This section allows the user to select the applicable system instructions in total, which include an ejector system with an integrated unit, an ejector system with discrete components, a vacuum pump system with integrated unit, and a vacuum pump with discrete components. Explanations of these systems are available on this page. For the purposes of our example, we will select ejector system with discrete components from the four options. Click on Next to proceed to the next page. We are now in the section for selecting a circuit structure. The amount of circuit structures available here varies, depending entirely on which system construction was selected earlier. The type of circuit selected on this page determines the number of model selection steps required, and these are shown at the top of the page. Since we have selected the ejector system with discrete components as our system construction, we are presented with four circuit structure options. For this example, we will select Circuit 1. The components required for this circuit are shown in the table. They are an ejector, tubing, vacuum pads, supply valves, directional control valves, and a restrictor. We can now move on to the next section. Click on the Next button. We will now fill in the input data page for model selection. The first thing we need to select is the lifting style. It can be either horizontal or vertical. We will keep the default, horizontal lifting, for our example. For adsorption response time, we will enter 0.5 seconds. This is the time it takes the internal vacuum pressure to reach the required pressure for adsorption, after the supply valve has been operated. For the safety factor, we will enter 4. This is the ratio of the theoretical lifting force and the workpiece weight. Please note that the safety factor for a horizontal lifting style should be a minimum of 4, and for a vertical lifting style, a minimum of 8. Our workpiece mass will be 1 kilogram. Our adsorption vacuum pressure will be -60 kilopascals. The quantity of pads for our application will be 1 pad. For leakage per pad, we will enter a maximum reference leakage of 5.3 liters per minute. This is obtained by clicking on the blue chevron button for the Reference Data of Leakage sub-window. Here the pad size, shape and material can be selected. If the required pad size is not listed, select the closest pad size used in your application. We are going to select the ZP40 pad with a flat shape made from NBR. The table at the bottom shows reference leakage rates for various materials. In our case, we will select rough wood as our workpiece material, which gives us a reference leakage between 4.04 and 5.3 litres per minute. Returning to the data input page, we also need to select the required length of tubing between the ejector and the pad. We will select a length of 1 metre. Lastly, we will enter 0.5 megapascals as supply pressure for this application. We have now completed this section, so we can click on the Next button to move on. We will now look at selecting the correct vacuum pad type for our application. This section allows the user to select from the full range of SMC vacuum pads by selecting All, or narrow the selection to a specific series of vacuum pads by selecting the ZP3, ZP2, or ZP series. The table shows the series, pad diameter, and pad types available for each of the options. In this instance, we will select All. We are now able to define our pad specifications from drop-down lists. Details of each specification and what they mean can be seen by clicking on the blue chevron button. For the purposes of our example, we will select a ribbed flat type vacuum pad with a non-rotating buffer which is made of NBR. For the vacuum inlet, we will use a 6mm one-touch fitting. The vacuum inlet direction will be lateral. Our buffer stroke will be 30mm. As we enter our pad specifications, the software generates a choice of vacuum pads to select from. We will select ZPR40CNK30-06-A14 for our application. Now that we have selected our vacuum pad, we will move on to the next section by clicking on the Next button. In this section, we will select the correct type of tubing for the application. This tube section applies to the tubing between the ejector and the vacuum pad, which is marked as L on the circuit diagram on the left. It is important to note that tube selection directly relates to the vacuum adsorption and release time. The software presents us with 7 types of SMC tubing material. Depending on what is selected, more options of the available tubing series and their specifications are made available in a table. For the purposes of our example, we will select metric polyurethane tubing. This is confirmed in the table as TU series. We can then add the colour blue and 20 meters per roll to the tube specifications. From the generated part numbers table for the TU series, we will select TU0604 BU-20. Now that we have selected our tubing, we can move on to the next section by clicking on the Next button. This part of the selection program looks at selecting an ejector. We are presented with 5 ejector series to choose from. Specifications for these are described in the table. For the purposes of our example, we will select the ZK2 series and base it on our application requirements. In the drop-down selection list, we will select a single unit body type and a vacuum ejector with a built-in silencer exhaust. Since we are using 6mm tubing, we can specify our vacuum and supply ports with 6mm diameter one-touch fittings. With these specifications, the generated selection table narrows down our options to 4 applicable ejectors based on their nozzle diameters: 0.7, 1, 1.2 and 1.5 mm. The table also shows the numbers of ejectors required for the application in the last column. We can see that the first option requires 3 ejectors with a nozzle diameter of 0.7 mm. Therefore, for a more compact system, we'll choose the second option, as 1 ejector will be sufficient. We can now go to the next section. Click on Next. We are now in the first of the 2 valve selection sections in this process. Valve selection will depend on which function and circuit was initially selected. This table gives a description of the available valves. We will select a VX2 series valve. In the drop-down specification, the software automatically defaults the operation method and body type to direct operated poppet type and body ported type/unit, respectively, as these are the only options available for the VX2. From the circuit diagram, we can see that we need a normally closed valve. The valve body material, in our case, is not important. However, as this is needed by the software, we will select resin. We are going to select a standard type specification. Since we are using 6mm diameter tubing, we will select 6mm one-touch fittings for port 1 and port 2 connections. The software now gives us a choice of 2 valves, the VX210H and the VX210J. Based on our operating pressure range, we will select the VX210J valve. Because of our selected circuit, valves V1 and V2 are similar, so we will not look at the selection process of valve V2, as it is identical to the selection of valve V1. After selecting our V2 valve, the next selection process is for restrictor SP. In this section, we are given a choice of 7 applicable speed controllers, with a table showing their specifications. We will select a standard resin-type speed controller, ASX002F. We now have 3 specifications to select from drop-down lists. We require a speed controller with 6mm connection ports, so we will select 6mm one-touch fitting connection ports with a standard hexagon lock nut. There are no additional specifications for a made-to-order special, so we will select None here. To select the correct product from the 3 available options, refer to the product catalogue for detailed specifications. For our application, we will select the AS2002F-06. This concludes the selection process. We can now look at the results in the Selection Results page by clicking on Next. Now let's look at the Results section of our model selection. The selection results show the products that we have selected for our application, as we've progressed through the different stages of the model selection software. The conditions input shows the user specifications that the user has specified in the input data section of the software. Our circuit diagram is shown on the left. The system characteristics are shown in this graph. The graph represents adsorption time and release time in relation to vacuum pressure. Adsorption time is represented in red, while release time is represented in blue. The black dot on the graph represents the time it takes to reach the specified vacuum pressure for the application, while the blue dot represents the time for the pressure to reach 95% of the maximum vacuum pressure. The blue line on the graph represents the vacuum release time. This is the calculation results panel. Any relevant precautions will be indicated in the precautions panel. In our case, we are notified by the software that if 3-port valves are selected as a 2-port valves, the empty port should be plugged. To change or modify data input in any section of model selection, click on any of these buttons. Click on the Return button to go back to the previous section, which in our case will be the Selection of Restrictor SP section. Click New to return to the Selection by Function page for a new selection or calculation. The Print button prints these results. Save to PDF saves these results as a PDF file. You can find your nearest SMC sales office by clicking on Contact. The next panels show the specifications of your selected models in detail. Model selection is a useful tool for helping the user find the right products for their specific applications. In the next part of this e-learning module, we will go through the characteristics calculation part of the software. To do so, we will click on New to return us to the Selection of Function section. Now let's have a closer look at Characteristics Calculation. Here we will calculate vacuum specifications based on our application and input conditions. After selecting Characteristics Calculation, we will select the same system construction and circuit as we have in Model Selection. We will now go through an example where a customer has 2 flat ribbed type vacuum pads made of NBR with a 30mm stroke non-rotating buffer. Along with these vacuum pads, they also have tubing, an ejector, 2 valves and a restrictor, all of which have the same specifications as we've previously selected, which means the model numbers will remain the same. Once we've selected the function, construction and circuit of our system, we will move on to the Input Data section of Characteristics Calculation software. Now let's look at the Input Data section. In Characteristics Calculation, the data input for adsorption time and safety factors are not required, as these values will be calculated by the software. We are going to input the same values as we used before, except for the pad quantity, as we have 2 vacuum pads this time. Workpiece mass is 1 kilogram. Adsorption vacuum pressure is -60 kilopascals, and leakage per pad is 5.3 liters per minute. Since we have 2 vacuum pads, we will need to identify the length of tubing, L2, between the branch and the vacuum pads. We will select 1 meter for L1 and 0.2 meters for L2. The supply pressure is 0.5 megapascals, and the number of simultaneously operated ejectors is 1. Once we have completed our input conditions, we shall move on to the next section, which is pad selection. Now let's have a look at the selection of pad section for characteristics calculation. Since we already know our pad specifications along with the model number, we can begin by inputting the specifications and narrowing down the list of pads below. The pads we require are flat rib type vacuum pads made of NBR with a non-rotating buffer of 30mm stroke and 6mm one-touch fittings. The model number we will select from the options provided is the ZPR25CNK 30-06-A10. Product selection in the characteristics calculation mode lists all models without any connection to input data specifications, unlike model selection, where the software narrows the choices down according to the specifications in the input data. Now let's move on to the next section of the characteristics calculation, which is the selection of tube, by clicking on the next button. In this section, we will select the same model of tubing that we've previously selected in model selection mode. Since we have selected two pads, we will need to specify two different models and lengths of tubing between the ejector and the branch-off, and tubing between the branch-off and the pads. In our case, we are going to select the same tubing model for both: blue polyurethane tubing with 6mm outside diameter with the part number TOO340 BU-20. We will not look at the next four selection steps here, as they are the same as the steps in model selection mode. We will skip to the selection result section. We are now looking at the selection result in the characteristic calculation mode. As you may have noticed, it is quite similar to the results section of model selection. All the result panels in this section are similar to the panels explained in the results section of model selection. The results here show the calculations based on the products selected and the input conditions. Based on our selections, the software has calculated that the adsorption vacuum pressure of our vacuum system would reach -38 kilopascals in 0.2 seconds. Also, the safety factor is 3.8. which is below the required minimum of 4. This means that our selected products do not reach adsorption pressure and safety factor requirements.